Alright, let's start. Hello everyone, welcome to the stream. Today we continue where we left off yesterday, which was I was doing gameplay coding, I think. We fixed a couple of bugs yesterday with the collision code and the camera. I added, let's see, yeah, I added texture mapping, or I changed how texture mapping works using this new window here. Then the game code we fixed. Let's see. We fixed the model of the player so that these two voxels, the right face of these two voxels, are now purple instead of black. Same thing here. And we implemented this new camera. I changed how wall jumping works. Yeah, it's feeling a lot better now. Yeah, that's what we did yesterday. Since yesterday, I actually did a little bit off stream. I worked a little bit off stream on this project. I changed it so that I can do wall jumps while sliding down now. So I can wall jump indefinitely. Just felt way more satisfying to do wall jumps all around. So I can basically do parkour now. Yeah, it's a lot more fun to do this while sliding down. It adds to the mobility of the player a whole bunch. Um, this issue here, so getting up this is very finicky. I basically need to slide up the wall when hitting the thing above. An easy way to fix that would be to make the player collision um, the player collision box smaller than a single tile. Currently, the player collision box is just as high as a single tile, so that's why it's so hard to get in there. The player just barely fits inside this gap, so you just have to stand just right to get in here. The same thing happens over here, where I can't fit into this gap easily. Basically, I have to make sure that I'm falling not too fast so I can kind of squeeze in there somehow. Um, I'm gonna change that today, so I'm gonna implement something that checks whether I'm trying to move to the left, and if there's a gap, I'm guaranteed to fit in that gap. So that's one of the to-dos for today. But before I do that, let me explain one other change I did off stream, which is I fixed a performance issue. Yesterday, when I switched into the GUI like this, uh, the frame rate dropped from 250 to 20 frames per second, the average frames per second. And currently, if the menu isn't being shown, it's 600, and if the menu is up, it's 300. So I made the rendering a lot more efficient, and that's the reason why I did that off screen, was because I thought it would be a lot more work, but it was surprisingly easy to do that. So before I did the change, the rendering pipeline was like this. I was asking the GPU for a vertex buffer, so just um, a memory region. I think I want 30,000 vertex vertices, So then the GPU returns a pointer to the beginning of the buffer, and I'm filling it in with data as the game progresses. And then when I'm finished filling it in, I tell the GPU, hey, I'm finished, now you can process this vertex buffer. And then the GPU renders this, I get a new buffer in the meantime and render the next frame. So that's the basic idea. So while the GPU is working on this, I'm filling in this, and then as the GPU renders this, I'm working on the next buffer. There was an issue though. What happens if I have a context switch somewhere here? So basically I want to use a different texture, right? What I did before was I said, hey GPU, I am done with this buffer, please render. And it was doing very little work, but I orphaned this whole buffer. That's what it's called. If you just discard the whole buffer, it's called orphaning. And I allocated a new GPU buffer, which I then filled also very inefficiently, and then told the GPU, hey, render this, and then I'm changing the texture again, and I get a new buffer. Basically, I was allocating whole buffers instead of just rendering a region, subregion of a buffer. So what I did off screen to make this more efficient was, as I'm filling this in, if I have a context switch, I unmap the buffer. I tell the GPU, hey, you can render this region, and I promise I won't touch this data. And instead of allocating a new buffer, I continue filling it in here. So I reuse the same buffer, and then if there is a context switch, I tell the GPU to draw this, and then I continue filling it. Essentially until it's filled up, and only then I allocate a new buffer. And that sped up the rendering by a factor of 2 when in idle mode, and when I have a lot of context switches, like when I'm rendering the GUI, it basically is 100 times faster now. Since it was 20 average frames per second, and now it's 300. So that's the basic idea. And I did that all by basically just writing one new function, which is called map buffers. This one, where I'm just mapping the buffer to a specific range. I'm telling the GPU this is the unsynchronized bit, which tells the GPU that I won't touch the data that's already in the buffer. So it's not that makes sure that there is no synchronization between the CPU and the GPU. Otherwise, I would have to wait for the rendering call to finish before I can touch the buffer. So my current rendering pipeline is, at the beginning of the frame, I'm orphaning the buffer from last frame. Since I don't care about it anymore, I need a new fresh buffer that I can fill from the start, beginning. And then as I go, I map subregions of that new buffer. And if that gets filled up in the same frame, I orphan it and get a new buffer. And that's turned out to be a lot faster. One way I could have fixed the performance issue from yesterday is also I could have used a texture atlas so that there aren't any context switches, and then the performance would be, I guess it would be actually better than now. But as it seems, context switches aren't that costly if you have no synchronization between the GPU and CPU. So basically, I'm just asynchronously doing context switches and queuing up render commands. So switching textures seems to be fine, as of now, at least. So now let's go over to the thing I want to fix today, which is fitting into this gap. I'm gonna do a recording here and then replay. And as this recording is playing, we will modify the code and see if we make any progress towards our goal. So the game loop is over here in this function. So at which point would I want the player to go into this gap? So let's think about this using paint. So let's see, there is a wall here, there is a wall here. The player is here. He's falling down, or maybe he's actually trying to move this way. He's colliding against the wall and his velocity gets corrected to this. So he's then sliding along the wall instead of running into the wall. So the point in which I want to squeeze the player into this gap is if the player is above the gap, but next frame he would be below the gap. That's the time where the player is supposed to squeeze in here. So I need a couple of informations, I think. I need a little bit of bookkeeping. I need to know that I tried to move into, basically that I was pressing left, so the player is trying to move this way, even though his velocity gets corrected into sliding along the wall. So to squeeze the player in here, I need to know where the gap is and whether it's time to do this squeezing in, which is, as I said, if the player is above the gap this frame, but next frame he would be below the gap. Okay, so first let's do some bookkeeping. We want to make sure that we know that the player pressed the left arrow key. This is camera code. This is where I set up the movement. Maybe I should make this be dependent on pressing left. The only thing I'm interested in is whether I'm moving to the left or to the right, regardless of whether that was caused by a key press. Hi Festek. Sorry about that. I got a call Where was I? I wanted to do some bookkeeping. Let's just store the original velocity, I guess, before we do any modifications like adjusting the velocity on the collision normal. So the original velocity is just the player velocity. So this way we always know whether the player tried to move left or right originally. And then, so this would be the place where I do broad face. I don't have a broad face currently since my tile map is just a very small array like this. So I'm not doing any broad facing currently, which is just unneeded. So instead, let's after the broad face, let's find position of gap and whether we should squeeze into it this frame. So basically we want to know whether the player is moving horizontally. It doesn't matter if whether he's moving up or down. The only thing that we're interested in is whether the player is moving left and or right while he's moving up and down. And if that's the case, we will be looking for this gap. And if it exists and the conditions are right for us to squeeze into this gap, we will make that happen. So that this here doesn't happen, so that the player goes into this gap instead of just sliding around like that. So one thing that we need to do to be able to look for this gap is I need the player coordinates in tile indices. The player coordinates are in vault coordinates, but the tiles are in a grid, so I need the player grid position, so I can check it against the tiles. So I need to know in which grid position the player resides in. And that is done like this. Yeah, we divide the player position by the player tile width, and then we floor it and turn it into an integer. Same thing, the player y position. So now I know where in the grid the player is. What I should have done before is check that the player is moving horizontally. No, that's fine. That is moving horizontally and also vertically. So basically he is moving. If he's standing still, we don't need to do any of these. Then we check the tile map, which is currently this thing. Okay. So I know the player grid position. Next, I need to check whether the tile in the X move direction is free. So if we are moving to the left, we need to check the tile one to the left of the player. Except I need to make sure that this is positive. Otherwise, we are at the edge of the tile map and I don't need to do any of these checks. Game map width, right? Game map width. Then we check whether the gap is actually existing, which is the tile ID is 0. So now we know that there is actually a gap. Next, we need to check whether the tile above and below it are solid. So these are solid tiles. Otherwise, that wouldn't be a gap. So there would be enough space for the player to just fit as it is. The player wouldn't have a problem fitting into a gap. Maybe I'm only interested in one of these tiles. So if the player is moving down, I probably should always make sure that the player, like even if this tile didn't exist and I try to go to the left while falling down, I should still make sure that I squeeze into this gap. So while moving down, I'm only interested whether this tile is solid and this one isn't. And that would make sure that even if I'm falling, even if my velocity is this huge value, I can still fit into gaps that are smaller than my velocity. So then we need to find out which neighbor we have to check, whether we check the above or below. For now, I will just assume that we are checking the neighbor above instead of below, since I have to make this work for a specific case first and then we will generalize it. So if the y velocity is greater than 0, that means the player is falling currently. Then we check the tile above the gap. which is calculated the same way. Then if the neighbor is solid, which is just to check that it's not equal to 0, we know that the gap exists. Okay, then I should probably have this outside. So if we got here, I'm doing it this way because I'm probably gonna have multiple paths here where I set the gap exists to true. But once I know it exists, it is just a single path from then on. If gap exists is true, it means I can read from this value safely. Then we're gonna calculate the bounds of the gap, because I need to know whether this is the frame where we have to do the squeezing in. If there is this gap, but let me draw this new. So this is the wall, the player is here, and he's moving down. If the next frame the player is here, it's not yet time to squeeze in. It's only time to squeeze in when the player is right at the edge, and next frame he would be below the edge. This is when we do the squeezing in. So to get the tile bounds, we do this calculation. I guess I need the gap coordinates also. We also need the translated player coordinates. Do I have that somewhere? Doesn't seem like it, okay. So it's the player bounding box translated by the player position, and the next. So the player position for next frame would be the same thing, except we also go by the velocity times delta time, of course. Now we need to make sure that it's time to squeeze in. which is if the player so currently I'm only checking the case where the player is falling down and he is just crossing this line where he is above the line currently, but next frame he would be below the line. If that's the case, we will be squeezing in. Milk1 asks how long you've been programming in C++. I've been programming since over 10 years. Although in C++, oh yeah, it's over 10 years. Although I haven't worked, I haven't had a programming job in C++ ever. I'm just self-taught and a hobby programmer, even though I've been programming for a long time. So what does it mean to perform the squeezing, which means we want to get into this gap? It means since we know that there is a gap, we know that we can safely place the player at this position. Okay. But I do not want to circumvent the collision checking. So this is before we do the collision checking, which starts here. So this is before we do any collision checking. So I do not want to circumvent the collision checking. If I falsely place the player here by just adding his velocity to his current position, I might be inside the tile. Instead, I want to be very conservative with the placement. So the only thing that I know that I can do for sure is I can place the player right at this edge, since we know that there is a gap. And I know I can place the player horizontally up to here, since I don't know the state of this tile, but I know that up to here at least there isn't anything in our way. So we will be calculating the difference between the current position of the player and this line. So I'm interested in this segment, which is the current player top value all the way around. It's the get bounce top minus the current player bounce top. And that's how much I'm allowed to change the player position. Yeah. Now the player is right at this line. Now we also need to push him a little bit horizontally so that we squeeze into this gap. So I need to make sure that we don't go over this boundary when I'm pushing the player to the left. So the player isn't allowed to be here all of a sudden. At most I can place him here. So this needs to be the min of the left position of the gap and the next player bounce left, and instead of max min it needs to be max since I'm moving to the left, and smaller x values are to the left, which means I need to get the max value to not move too far. But since this is the delta, I need to subtract from this So currently I just know how far I can move, but I need the delta. Well, I know the final position, but I need to know how much to move there. This is the I guess I can do then current player left. So this is the bigger value. I'm subtracting from it the smaller value, so this becomes a positive value, which is the wrong thing. I need it to be negative since we are moving to the left. Okay, let's try to compile. Alright. Doesn't seem to work. No, these aren't uninitialized. But fine. Okay, do we ever detect the gap? Yes, we do. The gap bounds are at this position, which looks reasonable. The player position also fine. Yeah. The next position is here, but this is never true. Do we ever get here? No. So that condition is never true currently. Right, so what is the problem there? So I'm checking that the player is above the gap currently, but next frame he would be below the gap. Why isn't that true? It's clearly at some point that should be happening. Let's try to go frame by frame here. Let's see, where's the frame counter? 481, 482, 493. Around 493 and 496, should that be true? Let's try to break here and see what happens. Why isn't this triggering? Gap exists false. Oh, okay, I know what the problem is. The problem is this calculation over here. In my drawing, I assumed that the player position is the center of the bounding box, but actually it's the bottom of the bounding box. So when the player just moves over this gap, so if the player is currently here, the tile I'm checking for whether it's a gap or not is this tile here. So that's why that isn't triggering. I need to check this tile. Or I can, so if I know I'm checking the bottom of the bounding box, shouldn't that still be triggering? That should still be triggering though, since if the player is here, I'm still checking this tile, and then next frame he would be below this threshold. But I'm still checking this tile, since I'm calculating the next player position forward in time. Okay, so why isn't this triggering? Is there a problem with my logic? Oops. Okay, let's break around here. We're looking for an allocator error. Oh, semicolon. Wait, why, what was that line supposed to do if there wasn't a semicolon? Did you try to define a function, or? The gap axis is false. 1512. Let's see, what is 1512? 15 is 15 lines. It's this line, so I'm checking this tile instead of this tile. You put semicolon, so it was declaration. Wait, but if I do that, void func, isn't this a compiler? Yeah. Didn't you get the compiler there? Why am I already getting the wrong index here? Floor should be right. This code. So let's just subtract 1 for now. This is kinda hacky. I'm just basically enforcing that we check the right tile. Still not. No, it never detects a gap at all. Wait, wasn't this working before? It never detects the gap. Clang is retarded. I don't use Clang that often. Okay, why? What did I change? Sixteen, 12, 15, 12? Wait, is that the problem? What? Ignore. So it's thinking the player is at 12. It thinks the player is currently here instead of here. That's why it's not triggering. Why is that? So if I add 2 to this, since it's 2 tiles off. Wait, it's 1 tile off. This is at 15, 14, 13, it's one tile off. Oh, there it is. We squeeze in. Okay, now why am I one tile off? Okay, let's first check how the bounding box is composed. So, okay, the bounding box. So this is the player position, and the bounding box is like this. So the player origin is indeed at the bottom of the bounding box. Then to get the grid index of the player, so these tiles are in a grid like this, and I want this index. What I'm doing is I'm dividing the player position by the tile width and height, so I get a number between 0 and 16, since the map currently is 16 by 16. But instead of getting this tile, I somehow get this tile. That's why adding +1 here fixed the problem. Why is this off by 1 though? Am I rendering the player wrong? And I accidentally have the player be actually like this? Could that be the case? Yeah, since otherwise that would explain why I am getting the tile above instead of below. So maybe, wait, let me look at this again. -4, 0. Oh, I was mistaken. The origin is actually at the top of the bounding box. That's why I'm off by 1. When falling down, I'm interested in this tile. But when I'm moving up, I'm interested in this tile. So I need to make this dependent on my velocity. So if my velocity is bigger than 0, we will add 1 to this. Also, I need to calculate the grid position of the next frame. Wait, no, I don't need to do that. Or actually, if I do this, then I don't need to do this check anymore. If I do it up here, so let's do that. Player position y times delta. This should be velocity. So only if the current grid position is unequal to the next grid position. So basically, only if I'm about to go over one of the tile boundary lines, so from here to here, which means I'm crossing over this line, only then do I need to check whether I need to squeeze into a gap. So only if I'm crossing over this line do I need to check whether there is a gap. And then all of this, then I don't need to do this check anymore. And we will move all of this code into here. And we do this. If we are moving down, we are interested in the tile one below the current player position, and this shouldn't have changed anything. We are still moving into the gap. But there is a bug currently, which is I'm moving a little bit too much. So I'm manipulating the player position directly by moving him into this gap. So he ends up here, but I'm not adjusting his velocity. So he has the same velocity as before. So when I then do the collision checking, I am moving this much extra. This much. So the amount I move the player when squeezing is not taken care of when I do the collision checking. So I need to make his velocity shorter by the amount I moved him. So let's get the x delta here. So the delta values are the amount I moved him when squeezing. There's a couple of ways I could do this. I could calculate the length of this vector and then subtract that much from its velocity. Is that the correct solution here? Yeah, I think so. So we need the length. Delta length is x delta times x delta plus y delta times y delta, and the square root of that. Then we get the player so we normalize the velocity, we get the magnitude of the velocity, and then we scale the velocity by its original magnitude minus the delta length. So basically we are making the vector shorter by the length of the delta. So we end up with this vector, which is shorter. And then we only need to assign the player velocity to this value. So this should make sure that we are not moving too much at that exact frame where we do the squeezing. Let me see. Oh, it's still looking like a huge jump there. It's actually fine. I think that's just because of the recording. Let me turn off the replay. Alright, now I have control again. Let's try to do that again. Yeah, seems to be pretty reliable. I guess I could change the tile map to have a better place to test this. Wait, let's do it like this. Right, from the left it doesn't work. From the right, I mean, since we didn't implement that case yet. Yeah, this seems fine. Next thing I want to test is whether we can fit into gaps if my velocity is really high. So let me jump from here. Yeah. So that gap fitting squeezing should be working regardless of my velocity. So let's try to fall even faster. Oops. Yeah, okay, that's fine. Let's record the case where I try to squeeze in from the right. There it is. And now we need to make this work. Let's see, where was the code? Right here. So I'm gonna move this. Right. I'm gonna move this down here. This is gonna be like this. And then we do this, and then if we are moving to the right, we instead add one. Then here I need to check whether gap tile X is within the bounds game map width. Let's compile. Okay, this seems to have worked. Why did this work? Pretty sure that the calculation here is wrong, since I'm using the left values. I guess it doesn't matter whether I use the left or right values, since the delta should be the same value. since, let's see, so how much is the player removing when squeezing in? Whoa, yeah, that was a huge jump. So I am actually calculating the wrong delta here. So float x delta. So if you're moving left, are we gonna calculate the delta like this? Otherwise, the calculation should look like this. It looks even worse than before. Yeah. Okay. Oh, this should be min. Oh, there it is. Yep. So what happened? I'm recording inputs. No, now I'm replaying inputs. Stop replaying. Interesting. I can only toggle off replaying if I'm recording. That's a clear bug. Where did that happen? So if I press O, I should be toggling replaying. Oh, yeah, that's why. Alright, let's test this out. I'm recording. I'm replaying. Wait, now I can't replay. Now it's only replaying as long as I hold the button down. Okay. What? Oh, this should be platform inputs. Okay, let's try again. So I'm recording and I'm replaying. Wait, still. It's only replaying as long as I'm holding the button down. It says is key pressed. This should be only true for one single frame. How does this happen? The weird thing is it was working with the buggy version, and now that I fixed it, it's not working. So recording works correctly, only when I'm pressing the button. It starts recording, and then when I press it again, it stops recording. But when replaying, it only replays as long as I'm holding the button down. Even though recording is implemented the same way as replaying. Is key pressed? Is key pressed, and then I toggle. Why is this working and this isn't? Is key pressed? Oh. I didn't recompile the platform layer. I'm a dummy. Okay, recording and then replaying. There it is. Oh, whoa! I did. So playing, recording. Alright. Now it's reacting to my key presses correctly. Alright, so that's fixed. This is working, this is working. So the next thing is, I want to be able to jump from this gap up here. So currently I can't do that, because as soon as I leave this gap, I can't jump. And jumping while in the gap results in me hitting my head on this tile, so my jump is then cancelled. The only way I can get up there is by wall jumping like this. And I'm gonna fix that by making it so that the player can jump for a couple of frames when he just left the edge of a tile. So if the player is here, this frame, and then next frame he is here, I want him to be still able to perform a jump even though he is in mid-air. Alright, so let's do recording again and then make sure that it's working. So record, jump, replay. Alright, I can't replay this since I need to change the player state. If I do any changes on structures, I can't do my live code editing, since that would break the memory layout. I need a spatial state. Like this, and then I need to keep track of the spatial state of the player, whether he's grounded or falling off or airborne. And the difference between falling off and airborne is, when the player is falling off, I can still perform a jump, but if the player is airborne, I can't perform a jump. If the player just walked off a tile, his state will be marked as falling off. So we are currently falling off a tile. And that state will decay into airborne after a couple of frames. So we have a couple of frames window to perform a jump after we just fell off a tile. And if we didn't jump in that time, the player state gets set to airborne, and after that we can't jump anymore until we are grounded again. That's the idea, and that's why I need the state timer, so I always know how long the player has been in this particular state, and if the player has been too long in the falling off state, we switch over to airborne. Set spatial state. I'm gonna write a couple of setter functions because when I'm changing the current state, I want to reset the timer also. So player state. So if the state is unequal to the current state of the player, we set the player spatial state to the state, and we reset the timer. And all this does is counts the state timer up, and then we check whether the spatial state is equal to spatial state falling off, and the state timer has been too long. So let's say we have a 4-frame window to execute a jump after we fall off, and if we exceed that time, we set the player state to be spatial state airborne, and at that time the player can't jump anymore when falling off. Now we have to actually keep track of the player state when doing collision checking. So this checks the grounded state of the player. This keeps track of which tile the player is standing on currently, and then checks whether we are still standing on that tile. So if I do an if here, where I check whether this condition is true, that means that we were standing on a tile, but we are not standing on a tile anymore. So in that case, you can go ahead and set the player state to falling off. We also need to do the delta time. Where am I doing? Let's do it right here. Process, spatial state, player, delta time. So we set the player state to falling off. Then when we collide and set the grounded tile we set the player state to be grounded. And the switch to airborne happens automatically. Except where do I do jumping? If I jump, this value should be cleared. Where do I do that? Wait, I don't do that? Okay. That's fine. So here we jump, and when we jump, we are gonna set the spatial state of the player to immediately to be airborne, so we can't jump immediately again. And probably, why am I accessing it like this? I should probably clear the grounded tile. I can make that automatically right here. If state equals spatial state, if it's not grounded, we clear the grounded index, the grounded tile index. But then when I do the S key pressed, so then I need to change how I jump. There needs to be an additional check here. Where do I jump? Right, this is the jumping code. I need to make sure that I'm in a jumpable state. So if let's write a function for that. Then we're gonna implement this. Which basically returns if the spatial state is either grounded or falling off. And I'm explicit about the two states where I can jump, because I could just say if it's unequal to airborne, but I might add more states in the future, like swimming or something else, in which case then that would be wrong. So there are only two states that are jumpable, and let's see if that worked. So now if I'm falling off, Doesn't seem like it's working. So let's render the player state values. Right here. State. Should call this spatial state timer, since the value it's relative of is called spatial state. And I need the new function const char get spatial state string Right, there's a player state and the timer counts up. As you can see, for a couple of frames it's getting set to falling off, but the window is way too small. So let's make that larger. This value, let's make this 10 frames. Alright, let's try it out. Nope, doesn't work. So let's make sure that I try to jump while falling off. Yeah, currently I'm falling off and the jump isn't executing. Let's see. Is, what did I call it, jumpable? So I'm just gonna break if I pressed up and the player state is equal to falling off. There it is. Alright. Oh, that's why I have this condition that the player has to be grounded to be able to jump. But I just said that he doesn't need to be grounded to jump, he just needs to be in a jumpable state. So that's a problem there. This needs to go away. Let's recompile. There it is. He jumps while being in mid-air, as you can see. There, he jumped. So what about this one? Wall jump. So I guess I check the jumpable state here too. Except no, I can't wall jump while airborne. So all the states are valid, except grounded. Okay, so let's make a new function. Is spatial state wall jumpable? And then implement this. That's the case if you're either falling off or we are airborne. So only these two cases. So wall jumping is still working. And as you can see, if I jump while on the ground, the wall jump attempt thing doesn't show up, which means this jump isn't being registered as a wall jump, which was an error that I had earlier, but that I always have to make sure that I don't re-implement that bug. And as you can see, now I can jump around this tile, since we can jump while we are falling off. Although the 10 frames seems to be a little bit long. I can jump while noticeably being in mid-air. So let's make that shorter again. So the max falling off time should be maybe 5 frames. Let's see how that feels. So if you look here, it tells you how big that window is. So 5 frames. It goes by really quickly. Only for a split second the player state shows up as falling off. And even that split second is enough to react to the falling off and jump around the tile. That's kind of funny. Yeah, I think that's fine. I haven't implemented this case yet, the squeezing for this case. Although, do I need that? Don't think I can actually implement this squeezing in a way that makes sense. Since in this case here, if I squeeze into that gap, it would look kind of wrong since the player would be teleporting into the gap. And if I slide into the gap, it's already working. So it's basically a matter of timing. I just realized something. I think I have a bug in the collision code where I make the player velocities shorter right here. So I have to compensate for the fact that I squeeze the player into this gap by making his velocity shorter by the amount I squeezed. So the resulting velocity is shorter so that I don't move too much in that frame where I did the teleport into the gap. But when I'm doing this calculation, I'm not keeping in mind the delta time. There is no delta time, this dt value. I need to make the velocity shorter based on the dt. Since this is the actual amount I'm moving this frame. And I'm only making the velocity itself shorter instead of the pre-multiplied delta time. How do I compensate for that? Is the original velocity? No, it's not multiplied with the dt. Okay. How do I do that? That's a mathematical question. Just a sec. Oops, sorry about that. So I could adjust the delta time. I basically have to make sure that this value is shorter by this amount. So the resulting velocity okay, so pre-multiplied is this value. Let's normalize this thing. And then I think I need to divide by dt again. So that when I multiply later, when I'm doing the actual collision detection, I get the right amount. Oh, is this right? Yeah, that is right, because I want to get back the pre-multiplied amount. So if I multiply by the dt and then divide by dt and then multiply later again by dt, I end up with this term. So this should be the actual correct way to do this. Let's check that that didn't introduce any bugs. So, oh, interesting. So when squeezing in, it's still looking correct. But I did actually introduce a bug that I just saw, which is, let's record right there. My y velocity changes for a frame, which is because of this line. Since I'm manipulating the velocity directly, I'm making the player slower for the following frames too, even though I just wanted him to move a little bit less for only this particular frame. So instead of modifying the velocity, I think I need to modify the delta time. Since the delta time gets reset for each frame. So the delta time is a value between 0 and 1, which denotes how much of the velocity I'm gonna move this frame. So if it's 0.5, I'm only moving this much this frame, even though the total velocity is larger than this amount. So next frame I might be moving this much, and then next frame I'm moving this much, and that's the delta time. So when I'm doing the squeezing, I need to reduce the delta time by a little bit so that it's compensating for the amount that I moved this frame, which is, I guess, it's simpler than this line. So this is how much I'm moving this frame, and this is how much I adjusted the player position. And then we go ahead and divide this by the adjustment. Wait, other way around. So this is the resulting length of the velocity after the adjustment. And this is, if I divide by the original length, I get a ratio of how much shorter the resulting velocity is in comparison to the original. And this vector here I got by multiplying this vector by the delta time. And if I reduce the delta time by this ratio, the resulting delta time will be here, and I get this value as I wanted. And this should be enough, I guess. dt. But actually, I don't want to modify DT itself since I am using DT for other stuff too. Instead, I'm gonna make it so that the velocity isn't gonna be multiplied by DT but by a copy of the DT. Velocity DT. So then all of these need to change to VDT, and then I reduce the VDT only. Okay, let's make sure that this is working. So this should fix the bug where the player gets slower if I hold... No, it's still there. And now I can't fit into the gap sometimes. Second ago, I slide it off without squeezing in. Well, okay, the problem is, doesn't happen here. Oh, there it does. So let's record that bug. Didn't happen this time. Didn't happen. There it was. So if I replay, there is the squeezing bug. So why is this modification becoming permanent? Why is it becoming... I'm not modifying the player velocity anymore. I don't understand. Did I forget to compile? Let's compile. No. So what if I remove this line? I get warnings and the bug is gone. So modifying the velocity delta time is the issue. But I don't understand why. Since I'm not changing the player velocity, he shouldn't be coming slower for the following frames. right? It looks like the player is jumping in mid-air. Right here, he's stopping for a second in mid-air, and then he starts falling again. I'm not seeing where that happens. Is it because I'm triggering a collision here? So which frame is it that he stops? 8, 20, 30, 840, 841, 42, 43. I think 43. Well, I could have just set a breakpoint here and then see what the frame number is. It's 844. So at this frame, what kind of collision am I triggering? I did collide. What's the normal? Oh, me doing the squeeze into the gap results in a collision with this normal. That's why the player is in mid-air. Because of this line. Wait, no. Wait, that wasn't the issue. Am I still in the same frame? Yes. Why did the velocity y values... Oh, because I'm triggering that collision, I'm masking off the y value of the velocity. So the problem is that the fact that I'm triggering a collision by squeezing, which shouldn't be happening. Okay, let's see which collision we are triggering. Wait, what? Oh, this is the wrong code. Again, this is where the breakpoint should have been. So which tile is this? 206. Okay. So let's break here, break if app platform info recording frame is equal to 844 and index is equal to, no, I forgot which, the value. Okay, recording frame is 844, that's correct. What was the tile ID? 206. So basically I know if this condition is true, this function is gonna return a collision, and I want to know why it's returning a collision. That's why I need to break before this function is called, and in the code in here I can only break after the fact. So now if I compile this, the compiler should break left. Is this a pointer? There it is. We can now see why this is returning collision. So the player is at the position 220, 208, and the bounding box is at this. So the bottom is 207, and I'm at 208. There shouldn't be a collision here. Nope. And the delta is negative. Why is this negative? That's the problem. The game thinks I'm moving upwards for a frame, even though I'm falling. That's why I'm triggering a collision there. Is my VDT negative? It is. That's the problem. I did the calculation wrong there. So this calculation here isn't correct. Okay, let's visualize what I'm calculating there. This is the velocity of the player. The unmodified velocity. And let's say the dt value is 0.7. So this is the amount of, this is the velocity that I'm gonna move the player position by for this frame, since this is dt. Then when I'm squeezing, I'm moving the player by a little bit, let's say this amount. I already moved the player since I did the squeeze into the gap, which means I need to move the player by this amount, just this amount. And I can't modify the velocity directly, since that changes the player velocity for the next frames too, and I only want to move this amount less for this frame only, so I need to modify dt instead. So dt needs to move over to here. So this is dt star. So I need to know how to calculate this value based on this vector. which I thought was this term, but that is too much. Oh, I just figured it out. I need to calculate how much this is in regards to the original vector, not in regards to this vector. Since delta time is relative to the original vector, I need to calculate the ratio of this magnitude to this magnitude, which is basically the problem was that I was multiplying by dt here. If I remove that multiplication, I now get this ratio, this amount, and if I subtract this amount from dt, I get this value. Alright. Let's compile and test that the problem doesn't exist anymore, and it's still there. Damn it. Let's try to get up there again. Record, replay, there it was. So if I break here, so dt is 0.3, and then it becomes negative, and that shouldn't be happening. Okay. Oops, why did I stop the game? Ratio. Okay. So the ratio, oh, I get the wrong ratio here. This should be 1 minus. I need the inverse ratio, what I'm currently, oh wait, I only needed to do this. So I need the ratio of this to, let me draw this new. This is the vector. I need the ratio of this to this, and instead I was calculating the ratio of this to this, and that's why it was such a big number. I need the smaller ratio. Right, compile. Let's try this again. Alright, it didn't happen this time, but I can't be sure that it's not gonna happen. So let's try to trigger it a couple of times. Right, I think we fixed the problem. Okay, let's try to test the same thing with from the right. Alright. Doesn't seem to be happening anymore. Great. Hey, I'm a ninja. Yeah, yeah. That's kind of funny. Let's see. squeezing into gaps seems to be always working now. You're never falling through gaps if I'm pressing in the direction of the gap, and if I don't press anything, we just fall as it is. Great. Oh, why couldn't I wall jump there? Oh, I guess I just missed the input. Okay, I guess this is looking fine now. Alright. I'm gonna take a short break of 10 minutes. See you in 10 minutes. Alright, I'm back again. So let's see, where did I leave off? We just fixed a bug where when I was pressing left while in a situation like this, I was stopping in mid-air because of my gap squeezing code, which enables me to squeeze into these gaps. But now it's fixed. But I have a different problem, which I just realized, which is currently when I'm doing the gap squeezing, I am only checking for one specific tile, whether that one is occupied or not. But consider this case where the player is up here and his velocity is huge like this. So we are moving multiple tiles down in a single frame. And the tile I would be checking whether it's there or not would be this one, and I would be missing this tile. What I should be doing is scanning starting from this tile down to this tile. I should be scanning this whole region for a gap, and then I would find this one. And if I'm pressing left while falling, I should be squeezing into this gap. So I need to be implement scanning in that situation. And I think I already have the beginning of that code. Do game, which is I already know these two tile indices, the start and the end. And since I'm only doing, where is it? Right here. This is the gap squeezing. I'm only doing the gap squeezing if I'm moving over a grid boundary like this. If the current grid position of the player is unequal to the next grid position of the player once I move down. Right? For small velocities, it means if the current position is this cell and the next position is this cell, it means I'm crossing over tile boundary, and only then are we gonna check this tile whether it's a gap or not. If it is a gap, we are gonna squeeze into it, but instead of doing the single check, I am gonna scan along these two positions. So I know where the current grid position is and where the next grid position is gonna be, and currently I'm assuming these are only one apart, but they can be apart a lot more if the velocity is high enough. And this is where we're gonna do it. So I need, right here I'm checking the tile to the left or to the right, depending on whether I am holding left or right, whether it's occupied or not. And I need to do this in a loop, and we're gonna loop from the starting position until we reach the next position. Yeah. So we start at the this should be no I is fine. At the player grid position, we go until there. Except I need to clamp this to the tile grid. Otherwise I would be moving outside of the grid, and then I don't need to check for collisions even. And player grid Y is inside the game, and the same thing for the next value, except the next value needs to be clamped. Is that correct? Why not clamp both? No, then I'm gonna get false positives. The problem with clamping is if the player is currently outside of the tile grid and I clamp the next position will also always be inside of the grid. Which isn't a problem. The problem is when I'm above the grid and I'm only... Wait, that's also not the problem. I guess the only problem is when I'm trying to squeeze into a gap while I'm outside the grid and my velocity is like this. This check here will make it so that I don't even bother checking the gaps since I'm outside the grid. That's a problem. But I can't also clamp the player position because that would mean I would be checking for gaps when the player is somewhere over here. Alright, that's a hard problem. I'm gonna ignore it for now. To do what to do if the player is outside the tile grid. Yeah, I'm just gonna ignore that for now. Alright, we are iterating over these two ranges, the current player Y and the next player Y, and we are gonna check all of these tiles. That's the idea here. So we move all of this into the for loop, but here we use I instead of this value. Or instead, let's set this equal to the I value. So then if I break here, once we find the gap, we are gonna break this way. This value is valid when we break, since I set it to equal to I. I need to truncate this. And now I'm realizing, why am I not doing this? Right. So I need to make sure that this is inside the tile, the tile grid. Otherwise, I'm gonna read outside the bounds of the array. Should I do that? I could clamp. I shouldn't be clamping, but I could. Let's do simple check for now. So we are checking whether this is true. So if it's not true, you're gonna continue. And we're gonna continue because I might end up inside the tile grid at some point. Okay. This should be enough. Yeah. I think we are now currently scanning along the line. I can check this very easily by stopping the game. And then breaking here. Then I'm gonna resume the game. The breakpoint's gonna trigger, and we're gonna modify this value. So we're gonna say we are moving to the left, and velocity is a huge value like this. Same thing with the player velocity. So we are moving to the left. This is a huge value. That was too much. Alright. Let's see what happens. There it is. We found the gap after scanning. Okay, and then let's let me see. I'm gonna pause the game so we can inspect the following frame directly. Where is the pausing? What did I call it? Replay step. So I need to set this to true. Okay, we are gonna break here, resume. I'm gonna set this to true. And this will pause the game. Interesting, the camera didn't catch up yet. And we should be inside the gap and not falling if I resume. And indeed, we are inside the gap and not falling. So even if I set the velocity to a huge amount now, we can still find the gap correctly. So scanning along is working. So we are never gonna miss a gap when falling. Good. What's next? Next, let's do the broad phase finally. And then I'm gonna refactor the code so it's not all inline in the main game loop. And I can add other players, since right now I'm only checking collisions for one single entity. So broad phase. This is where that should happen. So since I'm using tile-based collisions, grid-based I mean, I basically know by the player position and his velocity the region of tiles he could how to, well, I know where the player is in the tile grid. I know where he's moving, and based on this information I can calculate the bounding box of all possible places he could be while moving along this path. So he ends up here, but this is the swept region. His bounding box swept along this this vector, his velocity, and this is the bounding box of that swept collision rect. And using this bounding box I can then calculate the grid bounds of tiles that I need to check collisions for. So based on the player position and its velocity, I'm gonna calculate this bounding box, the red one, and using the red bounding box I can then calculate the grid positions of the tiles I need to check collisions for. Alright, the player swept AB is I think I already have a sweep function. It's this one. We are gonna sweep the player bounding box along his velocity. Yeah. The sweep function is pretty simple. It takes the original bounding box, and then depending on the sign of the delta component, it's gonna either extend the bounding box to the left or to the right or to the top or to the bottom. So if you're moving to the right, this bounding box is gonna be extended to this, and if you're moving down, it's gonna get extended to this. Then we are gonna get the grid swept tile grid region. So using this red bounding box, we now need the integer-based tile indices, which I can calculate using this function. So basically I'm turning this float-based rectangle to an int-based rectangle by tiling it using these tile widths and tile heights. Tile width and tile height. So then I get a integer-based rectangle. Except this doesn't make sense. The way I have written it, this is supposed to be this way around. Wait. How did I implement this? So I have rect and I multiply. Oh, this is for turning a tiled rectangle to floating point based rectangle. I need the inverse of that. Rect scaled. Okay, I don't have that function, so let's write it. Except I think I don't have it. Let's see. No, I don't seem to have it. So it's gonna look similar to this. Except does this need to be template based? No, I think I actually want this to be not. I don't need that to be templated because this function only makes sense for floating point rectangles when turned into index-based rectangles. So results, return results. So we are turning the floor of rect left. Let's get the inverse. Same with the height. Should this be seal or also floor? No, this the right should be seal, I think. let's see. Let's say the player is here. I want the left to be 0 and the right to be 1. So yeah, it needs to be seal. And that's why I said this. I can't make this templated since it doesn't make sense to use floor and seal in a templated fashion. And bottom, again, this is seal. Alright, then we're gonna use this function to get the tile grid region, and then over here, instead of looping over the whole grid, over the whole tile map, we will only be looping over the tile grid region that the player can ever be possibly in, since we did the sweeping region. So this will ensure that we are checking the minimum amount of tiles possible, and that is basically the broad phase for tile-based collisions. We just cut out the majority of collision checks just because we calculated the area of tiles that we need to check against. Let's make sure that we didn't break collision checking, since if I broke something we are gonna miss collisions, and that should be very visible. It doesn't seem like it. Right, I think we didn't break collision checking, so our broad phase is also working now. Good. So I can get rid of this to do. It's kind of funny, our broad phase is basically just 2 lines of code, but that's basically working. Sweep the bounding box along player velocity to get bounding box of sweep region. Then turn the swept bounding box to tile grid region that we need to check for collisions. Tiles outside this region can't possibly collide with the player. Great. Since we're using that value only down here, I think we can move this code down here. And I forgot to check do the same thing here. Right, I need to check again whether I broke something. Sorry, Sniz, I don't speak Russian. Oh, I did break collision checking. We are straight falling through tiles. Alright. What went wrong? So something with my bloat face. Let's see. Oh, this isn't relative to the player position, that's why. So I need to translate this. Wait, don't I have that already somewhere? Translate player AAB. Okay. Let's move this out from here to here. And then we can do this. And this, alright, collision detection is working again. Let's make sure that we are not missing any collisions. Doesn't seem like it. You wrote this one, believe me slowly, and I do not understand. Yes, I wrote this one. It's all of my code, if that's what you're asking. Alright, broad face implemented. It's just 2 lines of code. Okay, now it's refactoring time. We are gonna move these out into their own functions. Do collision detection. We are gonna actually let's take the whole app, the inputs. Wait, I don't need inputs, do I? Let's do take inputs for now, and I need the delta time. I only need the game state. Right. So starting from here down to here, is the collision code currently. We are gonna move that over to here, and then we do collision detection app inputs delta time. This should not compile currently. Yeah. So we don't know what the player is. Player is this guy. It reminds me of the game Need for Kill. Need for Kill? Right. Yeah, I can see the resemblance somewhat. Okay, this needs to know whether we are in a frame boundary. And that's only because I am doing input detect. I'm checking inputs in here, even though I shouldn't be doing that. Frame boundary. Oh, I guess we do have everything. Let's make sure that I didn't break anything. No, seems to be fine. Thanks for following, Sneeze. Okay. The next thing is, let's make it so that instead of making this all relative to a player, we are gonna make this relative to a collidable component. So we are gonna rename the player state to collidable. Since right now in here there isn't anything specific to a game itself. It's just collision stuff. Except there is a little bit of input in here, like the input buffer for jumping and the wall jump timings. So let's call this grounded. Or well, it's not strictly player state. I could make these so an enemy could also have all these fields. So this is actually something that can be grounded. and collide and jump. Um, so I guess grounded collide component. Except let's it doesn't necessarily need to be grounded. Grounded just means I'm applying gravity, so I need to keep track on which tile I'm standing. But if I don't apply gravity, it's basically just a bullet that I fired. So the component is gonna keep its velocity until it's gonna hit something. Collidable component sounds a little bit better. So this was player state before. Let's change all the player state stuff to collidable component. And then the player we are gonna change these to collidable. This can stay as player. Okay, then in the collision detection, let's go over to the game state. Instead of having a single component like this, we are gonna have an array of components. So let's make a collidable system that stores components. Let's have it store 10 currently. No, while I'm at it, let's make this correct all the way. So stack allocator, and then max entity max count. So this is gonna return a collidable system. So I have this function. Yes. So it's taking an allocator, a type, and a size. Allocator, the type is collidable component, and the count is max count. That's it. Then the game state is gonna have a collidable system. And when doing collision detection, instead of taking the app data, we are only interested in the collidable system. So I don't need the game anymore. I don't need the player state. Instead, we are gonna loop over all the collidable components. Like this. Move all this code into that loop. And then we need to change all of these things to be based on this entry. There's a bunch of them. So these become entry dot. Let's make sure there isn't anything called player in here anymore. Player, there is. Oh, this is bad. This shouldn't be existing entry. There is still player in here. Alright, let's try to compile. Bunch of bugs. Game grounded position. Let's just debug code. I can get rid of that. This is also debug stuff that I don't need anymore. Also debug stuff that I don't need anymore. Debug stuff. Although this right here, I might want to keep that, so let's keep the app data around for now. Alright, this is compile. So app, then app game state collidable system. So this should make it so that the player is hovering in midair. Of course, I didn't want that. What happened? What happened is the player is actually not in the collidable system. Collidable system, and I'm not initializing this collidable system currently. Let's do that first. So auto allocator is app stack allocator. Then we go ahead and say game collidable system. We initialize this using the allocator and let's say 10 entities. Then we go ahead and add the player. The player is gonna get initialized like so. Alright, instead of doing this inline, let's also move this out into function. So collidable component, add collidable component, it takes the system and then returns the collidable component. System entries and place back if result turn result equals, wait, this is wrong actually. It should be if system entries remaining, so there is room to add a component, then we in place back and then we initialize like this. and then we return the result. Yeah, add collidable component, game collidable system, game player equals that. So then the game state, this is gonna be a pointer. And then when I compile, I should get a couple of bugs. Because this reference is wrong. Wait, where was that? Oh, this is fine. These are pointers now. Alright, it's compiling again. Now if I go and check, yeah, we can control again, and it's component based now. Interesting, I can't jump outside of the tile grid suddenly. How did this happen? Why can I get out? What did I change? Wait, huh? There's a phantom tile here. Whoa. What's going on? There are phantom tiles. What? Are there tiles that I don't see? No? Oh, I know what it is. That's a bug with our broadface. I just read random memory and interpreted them as tiles. Whoops. I need to clamp the this tile region. I'm basically turning the player bounding box into tile grid indices, but then I'm not clamping them to the tile grid itself. So I was getting a region outside of the grid. Let's say the grid is here, and this is a region. And I was basically reading out of memory, out of bounds, and interpreting random memory as tiles. So if this is smaller than 0, it's gonna be 0. If it's bigger than the tile grid width, it's gonna be equal to the tile grid width, and so is the right. If tile grid region top is less than 0, and the same thing for left, for right and bottom. So if the right is less than 0, it means the left is also less than 0. So we can do both at once. Right, let's compile. And hopefully now I'm not reading random memory. Nope. Okay, if C++ or C had bounds checking for static arrays, I would have caught that. So let's make sure that this assertion, or if I wrote this assertion, I also would have caught that. And I didn't. Okay, so that assertion shouldn't be triggering. And just to make sure that that actually was the problem, if I uncomment this, if I comment it out, I should be getting that bug again. Why? I also need to make sure that this is bigger than 0. Okay, let's try it again. And there it is. So I was reading out of bounds. It's -1 at the beginning. So I was reading random memory. Can I generalize this? I can write a clamp function for integer-based rectangles. Oh wait, I already have that. It's called rectmin. Right, this should do the same as all of that code. Let's see, what is rectmin? It's just the max and min values of two different rectangles, and the resulting rectangle will always be inside this rect, or inside both of these rects, since it's the minimal rectangle that fits into both. And basically it returns, if I have a rectangle like this and a rectangle like this, it returns this region. Right. Okay, let's make sure that's working. Alright, we are not hitting the assertion, so I guess I did something right. I go out of bounds to the right. Okay, we're not hitting the assertion. Let's try left. Not hitting the assertion, and down also not hitting the assertion. Alright. It's working. Alright, one to do left. I guess I will do that tomorrow. Is to do factor out input code into separate function or system. Maybe I will implement an input system, so I don't have inline input stuff right here. That definitely needs to get out. Since I made this loop based, let's check whether I can add more components. Edit mode. No, do game. Right here. Let's add another component. And that's it. Oh wait, I'm not rendering components. Let's change the rendering code. Where do I render the player? Right here. Instead, let's make this render the whole collision system. So instead of player position, it's entry.position. Okay, now we should be seeing two. Where's the other guy? Oh, I'm controlling both of them. That's funny. Why am I controlling? Oh, I'm controlling both of them because the input stuff is inline to the collision detection, and I'm doing the input stuff for both entries, for both components. So definitely I need to refactor this. So I need a separate input system so that not every entity is controlled by the keyboard. Let's see. Currently, I can just cheat. I just want to see whether the other guy is working correctly. Let's see, auto first slash true. If not first inputs is clear. I meant to write this. Alright, this should make it so that the second entity doesn't receive inputs. And there it is. He just stands there. Interesting. Let's see. So I should make it so that the different entities stand at different depths so that they don't intersect like this. Also, it creates Z-fighting and it looks weird, right? But the second entity is correctly not taking inputs now. Alright, great. But that is a very, very bad hack. Let me undo this again. Instead, we will do this properly tomorrow by implementing an input system. Let's make sure that it's working again. So now I'm controlling both entities at once. That's why with one wall jump I get 2 wall jump messages. It would be funny if I can somehow get the two to unsynchronize, which would mean I have a very very bad bug in my code. But it doesn't seem like I can make them get unsynchronized. It might happen because of floating point inaccuracies, but doesn't seem to be happening, which means we are doing everything correctly. Great. Alright, this is a to-do for tomorrow. Input system and input components. What else? Let's format this code once. Okay, so thanks for watching. That's it for me for today. Tomorrow we will be doing some inputs. I will implement the input system so we don't control both entities. And we will be refactoring the collision code a little bit more so I can add multiple entities and some AI. I guess I might add some basic AI tomorrow too. So if you're interested in that, please tune in tomorrow. Don't forget to follow and like, and follow me on Twitter if you want notifications. Thanks for watching and see you tomorrow.